Welcome back, everyone. Before we close our fun-filled section on recursive methods, we wanted to look into one more frequently asked question around that is built around verification of your understanding of recursive methods in Java. Now, these questions usually come by developers who attend the interview process, and they want to check your understanding of recursive methods. We said before, and we'll repeat again, that one of the reasons why we said recursion is an optional chapter in our course is because things that can be achieved by recursion can also be achieved by loops, which is going to be our next major topic. So before moving on, let's get to our question. Now, there is a concept of finding a factorial of an integer in mathematics. So what does a factorial of an integer mean? It means that if you are asked to find for the result of a 3 factorial, by the way, the exclamation mark in mathematics is not the same as the not operator in Java. So exclamation mark in mathematics stands for factorial. So when you're asked to find for 3 factorial, you're asked basically to multiply 3 by 2 factorial. When you're asked for 2 factorial, the result for 2 factorial is 2 multiplied by 1 factorial. If you want to know what 1 factorial is, that's it. So 1 factorial is 1, and 0 factorial is also 1. Okay, so basically, we're gonna get until 0, and we're not even gonna look into 0 because 0 factorial is 1. This is given, right? So as 1 factorial is 1. So if you are to put these all in one line, if you are given to find for 3 factorial, you're going to be asked to find for 3 times 2 from coming 2 factorial, right? Times 1 coming from 1 factorial. Or if you want to use parentheses and see the longer version of this, 3 factorial is equal to 3 times 2 times well, I'm copying from here, right? And 1. Okay. Actually, let's lengthen it. 3 times 2 factorial. Right here. Right. Multiplied by 2 times 1 factorial. And etc. multiplied by 1. Etc. etc. So the formula for this, for n factorial, says that n factorial is equal to n minus 1 factorial times n itself. Now that you have this formula, now that you have this understanding of what a factorial does, let's try to code for the same. Let's put this aside. Let's put our nodes aside. And let's get back to our eclipses. So let's create a new class under the same section, 3_5. We're going to call this class Factorial Demo. Now, let's do this. Declare main method and create a public static int factorial. And this will accept an int parameter, and we're going to call it n. Right now, we're going to return -1. Obviously, factorial cannot return a -1, but we will do it so that we can change the return down the road. Now, first thing first, what we said about developing for challenging tasks is that we said create a pseudocode, analyze what the task is, create a pseudocode, and start coding for that. Start from the easiest part. The easiest part is if n is 0, then the answer is going to be equal to 1, right? So let's do that. If n is 0, return 1. We solved for one solution, right? We solved for one value. We cannot solve for everything else. So to start solving for everything else, now we need to add our else statement, right? Our else block. Now, we know that we have to call factorial in such a way, so we have to make a recursive call to a factorial in such a way that it is going to become, n is going to become 1 at some point, right? However, there is one trick in factorial. We said that factorial, to find the factorial, we need to get the previous number, so this number's factorial, and multiply it by our current number. So we need to develop a code like this. We need to say that int result that we're going to return is equal to n times this number times the recursion coming from here, from the previous factorial, from one lower numbers factorial. So let's do this. Let's call this a recursion. Let's declare a variable. We're going to call it recursion. So every time we're going to make a recursive call to factorial n-1, we're going to store it in our local variable called recursion. And then every time we get it, we're going to multiply it by our current value and return it as a result. So, and this return is going to become obsolete. It's going to be dead code. So try to understand what just happened here. We said that first case, if n is equal to 0, we're going to return 1. And what will happen is we coded for such a recursive call so as n becomes 1 at certain time, right? Now, the interesting point about finding a factorial is that we need to multiply the current number by n-1 factorial, right? By a previous number's factorial. So we basically took this. Let me copy this and add it to my comments here. We basically solved for this. We said that the result that I'm going to return is going to be n times m-1 factorial. So these three lines of code are there to demonstrate why we coded the way we did. However, if you want to code simply for the mathematics of it, you can do this. Return n times factorial recursive call of n-1. Okay, now we know that 3 factorial is equal to 6 because we said 3 times 2 times 1 is going to be the result of 3 factorial, and this multiplication is going to result in 6. Why don't we just call our method factorial, pass value 3, and test for it? I'm sorry, we have to print it. System out, we have to print the result. Run. Result is 6. 4 factorial is going to be 6 times 4, right? Because 3 factorial is 6. Run it. 6 times 4 is 24. You want to test your code, go to Google, find the factorial calculator, just put in random numbers and see what happens. Now, this is a demonstration for a solution of finding a factorial number using recursive methods. Until you get to this, it can look very complicated, right? How can we solve for it? Now, to get to this point, you have to use incremental development practice of analyzing the code, analyzing the task, understanding it, writing a pseudocode of how you're going to approach the task, then simply coding for it. When you do the first 2 parts, when you analyze and create a pseudocode, the Java part is the easiest. Sometimes it's a good habit to add, for example, I brought this comment at the later stage, but it is always a good habit to actually create a method, right? Let me actually create a public static void sample, right? Let's create a void method put parentheses, put comments, say step 1, I'm going to do this. Step 2, I'm going to do this. The next thing to do, right? So before even writing any Java related thing, any Java syntax, just put your steps in here, then code in between these comments. Comments are free, right? These are good for you to develop. Use a lot of system out print line, so print statements when you are developing to see the progress of your code, to see if it returns what you're looking for, right? Test for small pieces, then after you complete the method, you test for it, you validate that it works, take a leap of faith, remove your extra comments that might seem too simple, make sure you have Java doc comments, and then your code is going to be pristine. You're good to go. Okay, break things down, analyze them, create a pseudocode, add comments, start developing, and you're going to be okay. So I want to thank you for your time. I want to ask you to try this method out. Create a stack allocation, stack memory visualization for this method. Understand what happens, visualize it, and that's all it is about recursive methods. Thank you very much for your time. I hope these materials helped you, and I will see you in our next interesting and major section. Have a great rest of the day.